Hi students, have you ever wondered why the diamond sparkles? Does the number of sides affect the sparkle? In fact, it does. A diamond has 8 sides. Today's topic is about polygons. In this video, we will go through, firstly, what is a polygon? Second, the difference between a regular and irregular polygon. Third, sum of all the interior angles of a polygon. And finally, we will find out the sum of all the exterior angles of a polygon. So what is a polygon? It's a plane figure which is made out of more than 3 line segments. Here are a few common polygons. A 3-sided is known as triangle, 4-sided a quadrilateral, 5-sided a pentagon, 6-sided a hexagon, 7-sided a heptagon, 8-sided a octagon, 9-sided a nonagon, 10-sided is a decagon. Please remember these common names of the polygons. So for any n-sided polygon, it is commonly known as n-gon. A 19-sided polygon can be named as a 19-gon. Can you name the polygon of this famous US military installation? It's the Pentagon. There are 2 types of polygon. A regular polygon has sides of equal length. Hence, all the interior angles will be equal. However, for the irregular polygon, not all the sides are equal. Hence, all the interior angles will not be the same. Let's classify a convex and a concave polygon. For a convex polygon, all the points will be pointing outwards. For a concave polygon, at least one of the points will be pointing inwards. Let's take a look at these polygons. Can you identify the convex polygons for me? Only B and E are the convex polygons. Now, can you notice the interior angle of a convex polygon and the interior angle of a concave polygon? For the convex polygon, each interior angle is smaller than 180 degrees. For the concave polygons, one or more interior angles can be greater than 180 degrees. Now, let's find the sum of interior angles of a convex polygon. For a 3-sided figure, which is the triangle, the number of sides it has will be 3. The number of triangles formed will be 1. Hence, the sum of the interior angles of a polygon will be 180 degrees. Now, for a 4-sided polygon, how many triangles can we form? We can form 2 triangles. How do we get 2? Will be number of sides minus 2. Hence, the sum of the interior angles will be 2 times 180, which is 360 degrees. For 5-sided, number of triangles formed will be, let's choose a point. Number of triangles formed will be 3. Will be the number of sides minus 2. Hence, the sum of all the interior angles will be 3 times 180, which is 540. Now for a 6-sided polygon, number of triangles formed will be, let's choose a point again. will be number of sides minus 2 to hence the sum of all the interior angles will be 4 times 180, which is 720 degrees. Therefore, in general, for any n-sided polygon, the number of triangles formed will be number of sides minus 2. The sum of all the interior angles will be n minus 2 times 180 degrees. Can the formula be applied to a irregular polygon? Let's examine this six-sided polygon. Sum of all the interior angles of the regular polygon six-sided will be six minus 2 times 180 degrees. How about the irregular six-sided polygon? It will still be number of triangles formed will be 6 side minus 2 times 180 degrees. Now, how about the individual interior angle of a regular six-sided polygon? Since all the sides are equal, the individual interior angle will be simply sum of all the interior angles divided by the number of sides. However, for the irregular polygon, not all the sides are of the equal length. Hence, we cannot find an individual interior angle of the irregular polygon. Therefore, if it's a 20-sided regular convex polygon, an interior angle will be simply the sum of all the interior angles divided by the number of sides. Hence, in general, for any n-sided polygon will be sum of all the interior angles divided by the number of sides. Now let's move on to exterior angles. In this triangle, angle A, B and C will be your interior angles. By extending the sides of the triangle, angle P, Q and R will be your exterior angle. Each exterior and interior will form a pair of supplementary angles. With a sum of 180 degrees. Now let's practice on this pentagon. I will extend all the sides and I'll keep all the direction to be the same for consistency. The exterior angle will form 180 degrees with the interior angle. Now, can you identify the exterior angles of these following polygons? Did you get it right? Now, does the direction of the extension matters? For the diagram on the left, all the extensions are of the same directions, whereas the diagram on the right, the directions are not of the same directions. Now let's look at this pentagon again. Let's say I choose to draw my extension the other direction. The interior angle will form a vertical opposite angle. Because of this property, the exterior angle form will be the same. Hence, the direction of the extension does not matter. Okay, finally we will discuss about the sum of the exterior angles of a convex polygon. But first, let's take a look at this simulation. The exterior angles of this polygon has been already highlighted in yellow. Now, look closely as I drag all the points. What do you notice? The sum of all the exterior angle. Let me repeat again. I will be dragging all the exterior angles to a point. What will be the sum of all the exterior angles? So the sum of all the exterior angles will be 360 degrees. How about the individual exterior angle of a regular polygon? It will be simply the sum of all the exterior angles divided by the number of sides. Can we find the individual exterior angle of a irregular polygon? The answer is no, because the irregular polygon does not have lengths of equal sides. Hence, we cannot find the individual exterior angle. That's all for today's topic. Thank you.